Hello student, today we discuss about PYQS of electrostatic. First question that was asked in AIPMT 2010. Two positive ions each carrying a charge Q are separated by a distance D. If F is the force of repulsion between these two positive ions, then the number of electrons missing from each ion will be. We have to find out the number of electrons missing from each positive ion. That means we have to find out N. So according to Coulomb's law, the force of repulsion between the two like charges, that is Fe is equal to K Q1 Q2 by D square. Here Q1 and Q2 are the two identical charges, so Q1 Q2 is equal to Q, and according to quantization of charge, Q is equal to Ne. So F is equal to KQ square by D square. In place of Q, we put the value of Q is equal to Ne, so N square E square. So F is equal to K. In place of K, Coulomb's constant K is equal to 1 upon 4 pi epsilon naught. In place of Q square, that N into E, so Q square is equal to N square E square divided by D square. So subjecting N square, because we have to find out the number of missing electron from each positive ion, so N square is equal to F into 4 pi epsilon naught D square, that is cross multiplication. F is equal to F into 4 pi epsilon D square divided by E square. So N is equal to square root of 4 pi epsilon naught F D square by E square. Option number D is correct for first question. Question number 2 that was asked in AIPMT 2010. A square surface of side L meter in a plane of paper is placed in a uniform electric field E volt per meter acting along the same plane at an angle with horizontal side of square as shown in figure. The electric flux linked to the surface in the unit of volt per meter is. So here in the diagram, the angle between the electric field and area vector is always perpendicular to the plane of the surface, which is outward or inward, but it is always perpendicular to the plane of the surface given. So here the electric flux linked to the surface is given by flux phi E is equal to E, where E denote the electric flux, is equal to E dot dA. That is E is equal to electric field and dA is the area vector. The angle between the area vector and the electric field line here is E perpendicular to A, because electric field and area vector are perpendicular to each other. So theta is equal to 90 degree between them. So electric flux phi E is equal to EA cos 90, and cos 90 is always 0. So electric flux linked through this plane is equal to 0. So the electric flux passing through the given surface is 0. It is just touching outside the surface, but no electric field line passing through or actually crossing through the surface. There is no electric field line crossing the surface or passing the surface. Electric flux just touching the surface. So no electric field line crossing the surface. So the net flux is equal to 0 because of E perpendicular to A. Because here the electric field is perpendicular to area vector. That's why the theta is 90 degree between them. So electric flux passing through the given plane or surface is 0. Option D is correct. Question number 3. The three charges each having plus q magnitude are placed at a corner of isosceles triangle ABC of the side BC, AC and AB. Here D is the midpoint of BC and E is the midpoint of AC. The work done in taking the charge Q from D to E. So in order to transfer the charge from D point to E point, we have to find out the work done in taking the charge Q from point D to E. Triangle, given triangle ABC is isosceles triangle. The property of isosceles triangle is AC is equal to BC. The two sides AC and BC are equal, where D and E are the midpoint of BC and AC respectively. As per the geometry, that BE is equal to, that is your BE is equal to AD, and the charges at ABC are equal, and point D and E are equidistant from all these three charges. Here the point D and E are equidistant from A, C and B, because plus Q charge are placed on the three corner of triangle, and D and E point are equidistant from this ABC point. So hence by symmetry can be proved that the potential at D and E are equal. These D and E are equipotential point. That's why VD equal to VE. Here according to the geometry of the triangle, isosceles triangle, that B equal to DA, and the D and E point are equidistant from C, A and B point, because the charges are at placed at ABC, which are equal from this D and E point. That's why from the symmetry, by the symmetry, it can be proved that the potential at D and E are equal. So VD is equal to potential at D equal to potential at E. Now for equipotential surface, the work done is 0, because work done in moving the charge from D to E will be double according to the definition of V, that is potential or potential difference. Delta V is equal to work done per unit charge, that is in joule per coulomb. So here, due to the Vd equal to VE, that is equipotential point, that's why delta V equal to 0, because there is no potential difference between these 2 points D and E. That's why delta V is equal to 0. So no work is done in transfer the charge from D to E, because potential difference is 0, because here D and E point are equipotential point. So W is equal to Q, V minus Vd, and both are equipotential point. So there is no potential difference between these 2 points. That's why the work done in transfer the charge from D point to E point equal to 0. Option C is correct. That was asked in AIPMD 2011. Question number 4. Two metallic sphere of radii 1 cm and 3 cm are given the charge of -1 into 10 to -2 coulomb and 5 into 10 to -2 coulomb respectively. If these are connected by a conducting wire, the final charge on the bigger sphere is. So here the two charges are given, the charge Q1 and Q2, which having the radius R1 and R2 respectively. The sphere having radius R1 is equal to 1 cm, and sphere having the charge Q2 is the radius is given for this bigger sphere is 3 cm. Now these two are connected by a conducting wire. So when the two charged sphere are connected with each other by a conducting wire, which is a metallic wire, the flow of charge will take place between the two sphere until the potential of both sphere will become equal. The charge is transferred from higher potential to lower potential until the potential of both the sphere becomes same. So here the potential of big sphere is equal to potential of small sphere when there is no charge moving from higher potential to lower potential. That means that both having equal potential. So the potential of bigger sphere is equal to potential of smaller sphere. Now according to the definition of potential due to point charge, that is equal to kq by r, or that is nothing but r is equal to distance between these two charges. So here kq by r2, and for smaller sphere kq by r1. In case of sphere, the distance is taken as radius. So for sphere 1, that is kq1 by r1, that is smaller sphere, and for bigger sphere, that is the formula, according to the formula of potential due to point charge, the bigger sphere, the potential of big sphere is kq2 by r2, and here we take r as a radius in bigger sphere and smaller sphere. So kq2 by r2 in place of v big, and v small, that means the potential of smaller sphere, that is kq1 by r1. Now equating these two, kk cut on the both side, so remaining quantity q2 is equal to r2 by r1 into q1. Here the radius of r2 is given as 3 cm and radius of smaller sphere is given as 1 cm. So 3 by 1 into q1, so q2 is equal to 3 times q1. Now the net charge on the system is total, the sum of q1 plus q2, that is equal to q, and the net charge, that is 4 into 10 to minus 6, that is already given, that having the charge, the smaller sphere having the charge of -1 into 10 to minus 2 coulomb, and bigger sphere having the charge on it is 5 into 10 to minus 2. So sum of these two is 4 into 10 to minus 2. So q net on the system is 4 into 10 to minus 6 on the left side, and q1 plus q2, and from this equation, that is q2 is equal to 3 times q1, put the value of q2, that is equal to 3 q1. So on the RHS side it becomes 4 q1, and 4 q1 is equal to 4 into 10 to minus 6. So q1 is equal to 10 to minus 6, that is a charge on smaller sphere. So from this q2 is equal to 3 q1, that is the charge on bigger sphere is 3 into 10 to minus 6 coulomb. That is required in the that is the required answer in a question, that is q2 is equal to the charge on bigger sphere, that is 3 into 10 to minus 6 coulomb. Option number A is correct. Question number 5, that was asked in AIPMD 2011. 4 electric charges plus q, minus q, and minus q are placed at the corner of square of side of 2L as shown in figure. The electric potential at point A, midway between the two charges plus q and plus q. As shown in figure, the point A is the midway between the two positive charges. So denoted as A, B, C, D, E square, and the square having the side is equal to 2L. As shown in figure, A is the midpoint of BE side. Here AE and BE are equal, which is equal to L, and according to this geometry of the triangle, that is AD and AC is nothing but it is equal to, according to Pythagoras, that is under root AB square plus BC square, and AB is nothing but L square, and that your BC square is 2L whole square. That means after solving this, it comes out to be root 5 times L. AC and AD that is equal to root 5 times L. Now the potential due to the point charge, that is V is equal to KQ by R, where R is the distance and K is the Coulomb's constant. If Q is greater than 0, that means Q is positive, V is also positive. If Q is less than 0, that means V is also less than 0. So due to the potential at point A, due to these plus Q charges that is at placed at point B and point D, the potential is positive. So potential at point A due to this rest of the four charges, VA is equal to K in bracket Q upon AB plus Q upon AE. That is the distance between this A to E and distance between this A to B due to these two positive charges. Now the rest of other charges placed at D and point C is minus Q. So due to this minus Q charge which is placed at point D and minus Q charge placed at point C, the potential at point A is nothing but KQ by root 5 times L, because the magnitude of this AD and AC we calculated, that is root 5L. So due to these two negative charges which is placed at D and point C, that is minus Q divided by root 5L minus Q divided by root 5L, taking K is common, K is nothing but 1 upon 4 pi epsilon naught. So potential at point A, VA is equal to 1 upon 4 pi epsilon naught. After simplifying this, QL plus QL, that is 2 times Q by L, and minus Q divided by root 5L minus Q divided by root 5L, it becomes minus 2 times Q by root 5L. So taking 2Q by L as a common, VA is equal to 1 upon 4 pi epsilon naught. 2Q by L is taken outside of bracket. In bracket remaining quantity is 1 minus 1 upon root 5. So our answer is that VA is equal to the potential at point A due to this B, C, D and E point, that is 1 upon 4 pi epsilon naught 2Q by L in bracket 1 minus 1 upon root 5. Question number 6. The two pit ball carrying equal charges are suspended from a common point by a string of equal length. The equilibrium separation between them is R. Now the string are rigidly clamped at half height. First of all, the two pit ball carrying equal charges, that is plus Q, which are separated by distance R. The height is Y is given in the first figure, that is here. And now the second case, that the string are rigidly clamped at a half of the height, that means at Y by 2, that is Y is here in the first case. Now the height is half of the first case. So let the length of the equilibrium separation between the ball now become, we have to find out the separation. Let the length of string be Y and the mass of ball be M, and the charge on each sphere is Q. So here the free body diagram of this string, in a string there is a tension which is away from this pit ball. So that sigma fx is equal to sigma fy, that is your sigma fx is equal to 0. That means the force in x direction is equal to 0. The summation of force in x direction is equal to 0 and summation of force in y direction is equal to 0. Here it makes an angle theta with the string, so that alternate angle, that is z. So this angle is also theta, and that is your tension which is developed in the string. So the tension is always away from the pit ball. So the vertical component here is T sin theta, and that your horizontal component is T cos theta, and the pit ball having mass m, so W equal to mg, that is act always downward, and Fe is the force of repulsion between these two charges, because these two are plus Q like charges. So due to this plus Q charge, there is a force of attraction. This tends to move this pit ball away from this one. That's why the electrostatic force in the negative x direction. So sigma fx here, you can say that is your Fe is equal to T cos theta, because that is your horizontal forces which are equal, and vertical forces, that is T sin theta in the upward direction, and W equal to mg, that is your the weight force that is act in downward direction. So T sin theta equal to mg, that means sigma fy is equal to 0 and sigma fx is equal to 0. Now from the figure, that tan theta is equal to y by r by 2, that is y divided by r by 2. So tan theta is equal to 2y by r. Here tan theta in this triangle, that tan theta is equal to, that distance is half r by 2, so tan theta is equal to y opposite side divided by adjacent side r by 2, so tan theta is equal to 2y by r. Now at the equilibrium, the sigma fx, the horizontal force is equal to, the summation of horizontal force is equal to 0 and the summation of vertical force is also equal to 0. So T sin theta equal to mg, that is your equation number 1, and T cos theta is equal to electrostatic force, that is k q square by r square, because the both charges are identical, q1 q2 is equal to q, that's why k q1 q2 by r square. So in place of k q1 q2 by r square, we put here k q square by r square. Now taking the ratio of first and second equation, that is T sin theta divided by T cos theta, it becomes tan theta is equal to mg by k q square by r square. So mg upon k q square into r square, because this r square comes to numerator, so tan theta is equal to mg upon k q square into r square. And from the geometry of the figure, that tan theta is equal to 2y by r, so in place of tan theta we put the value here, tan theta is equal to 2y by r is equal to mg by kq square into r square. So 2y by r is equal to, that mg by kq square take as a constant c, so c is a constant, in place of mg by kq square we put here c into r square. So 2y is equal to c into r cube, so r cube is equal to, that r cube is proportional to y, so r is proportional to y has power 1/3, that is your equation number A. At a height of y dash is equal to y by 2. Now the second case consider, that at half of the height, that y dash is equal to y by 2, r dash is proportional to y dash has power 1/3. From this equation number A, that r is proportional to y has power 1/3, so r dash is nothing but r dash is proportional to y dash power, y dash is power 1/3, and y dash is nothing but half of initial height, that is y by 2. So in place of y dash we put here y by 2 has a power 1/3, so r dash is proportional to y by 2 has power 1/3, that is equation number B. From equation number A and B, that divide equation B by A, that is r dash divided by r, that is r dash is proportional to y by 2 has power 1/3, and r is proportional to y has power 1/3. So r dash is equal to y by 2 whole power 1/3, and r in place of r, that is r is proportional to y has power 1/3. After solving this, y has power 1/3 divided by 2 has power 1/3 in denominator, that is 1/3, so this y has power 1/3 cancel, so the r dash by r ratio, it becomes 1 upon 2 has power 1/3, so r dash is equal to r in cube root, that is 2. So r dash is equal to r by 2 has power 1/3, or in cube root, that is 2. So B option is correct of question number 6, that was asked in NEET 2013. That the separation between the pitch ball now become that y is equal to r divided by 2 has power 1/3, or in place of 2 has power 1/3 we put cube root of 2. Question number 7, a small charged particle of mass m and having charge q is suspended by insulated thread in front of a very large conducting charge sheet of uniform surface charge density of sigma, that is your charge q, which is having mass m, suspended in front of this infinite plane sheet of charge having a surface charge density sigma. So the angle made by the thread with a vertical in equilibrium is, we have to find out the angle theta. Under the equilibrium condition, the sigma fx is equal to 0 and sigma fy, that means the vertical force is equal to 0, so summation of vertical force and summation of horizontal force is equal to 0. From this figure, there is a free diagram that that theta having the angle made by the string with the fixed support. So from the geometry, that is your alternate angle, so T cos theta is your vertical component of tension, because the tension is developed in the string which is always away from the mass m or charge q. So T cos theta is your vertical component and T sin theta is your horizontal component, and there is a electrostatic force, that is QE, F is equal to QE, Fe is equal to QE, that is in the plus x direction, and W equal to mg, that is your weight force acting downward. So from the free body diagram, sigma fx is equal to 0. Under the equilibrium condition, the horizontal force, the summation of horizontal force is equal to 0. So the horizontal force is nothing but T sin theta is equal to QE, and that T sin theta is equal to Q by E, and the electric field due to the infinite plane sheet of charge is equal to E is equal to sigma by 2 epsilon naught. So in place of E, we write here sigma by 2 epsilon naught. So T sin theta is equal to Q sigma divided by 2 epsilon naught. That is equation number 1. Now the summation of vertical force is also equal to 0. So T cos theta is equal to mg. So that is your vertical component T cos theta of tension. It is equal to the W equal to mg. That is your weight force. So T cos theta is equal to mg. Now dividing equation 1 by 2, that T sin theta divided by T cos theta, it becomes tan theta is equal to Q sigma by 2 epsilon naught from equation number 1. That is T sin theta is equal to Q sigma by 2 epsilon naught in numerator, and in denominator T cos theta is equal to mg. So after dividing 1 by 2, that tan theta is equal to Q sigma divided by 2 epsilon naught mg in denominator. So theta is equal to tan inverse of the Q sigma upon 2 epsilon naught mg, that is in bracket. So theta is equal to tan inverse sigma q divided by 2 epsilon naught mg. That is your option number A, that the angle made by thread with the vertical equilibrium, vertical in equilibrium. Option number A is correct. Question number 8, that is in a region the potential is represented by V of x, y, z. That is the potential is represented in Cartesian form, that is V of x, y, z in 3-dimensional. That is V of x, y, z is equal to 6x minus 8xy plus minus 8y plus 6yz. That is V of x, y, z is given, where V is the potential in volt and x, y, z are in meter. So the electric force experienced by a charge of 2 coulomb situated at a point of 1, 1, 1. So x, y, z is given as 1, oblique 1, oblique 1. So these four options are given. So from this formula, that V of x, y, z, that is already given 6x minus 8xy minus 8y plus 6yz. So the electric field in the x component, the electric field in x direction Ex is equal to minus del V by del x. So we have to differentiate the potential with respect to x, that that is minus is outside. The differentiating the 6x with respect to x, it is given 6 minus 8y, that these two terms containing the x, the rest of other term does not contain x. So this the differentiation of minus 8y plus 6yz becomes 0. So minus is outside, because the component of electric field in x direction is equal to minus del V by del x is equal to minus 6 plus 8y. That is your electric field in x direction. Now similarly, electric field in y direction is the differentiation of potential with respect to y, that is minus del V by del y. That is the three term, that is first term, second term and third term containing that these three term, that is second, third and fourth containing y. So 6x, the differentiation of 6x with respect to y is equal to 0. Here is 8 minus 8x minus 8 plus 6z. So this is minus minus plus. So plus 8x plus 8 minus 6z. That is your electric field in y direction. Similarly, electric field in z direction, by differentiating V potential with respect to z, it comes out to be minus 6y, because only the last term that contain the z. So electric field E, the net electric field is equal to Exi cap plus Eyj cap plus Ezk cap. That is electric field in x direction, that is unit vector, along with this I cap, Ey and j cap plus Ez into k cap. So put the value of this Ex, Ey and Ez in this final equation. We get E is equal to minus 6 plus 8y I cap plus 8x plus 8 minus 6z j cap minus 6y k cap. So E is equal to, that put in a place of x, y, z, that is already given, that is in meter, that is 1, 1, 1. So in place of x, y, z, we take the value 1. So E is equal to minus 6 plus 8 I cap plus 8 plus 8 minus 6 j cap. In place of x, y, z, we put 1, and here is also 1. So minus 6 k cap. So finally, E at a distance 1, 1, 1, it is equal to 2 I cap plus 10 j cap minus 6 k cap. So the magnitude of electric field E, that is the square root of 2 square plus in square root, that is the component of x is the coefficient of x is 2, that coefficient of y is 10, and coefficient of z is minus 6. So in square root, that is 2 square plus 10 square minus 6 square. So it comes out to be, the magnitude of electric field is square root of 140. So that is 35 forza. So after simplify this, that is 2 under root 35, that is that much Newton per coulomb, that is the magnitude of electric field. So what is the electrostatic force? In a question they ask the electrostatic force on the charge, that is Q is equal to 2 coulomb, that is given. So that Fe is equal to the electrostatic force or electric force, Fe is equal to Q into E, and the magnitude of E is nothing but 2 into square root of 35. that is the charge is 2 coulomb and electric field is equal to 2 into square root of 35, so 4 under root 35 Newton. That much is the electrostatic force experienced by the charge when it is placed in electric field. So option D is correct. That was asked in AIPMT 2014. Question number 9. An electric dipole is placed at an angle of 30 degree with electric field intensity of 2 into 10 raised to 5 Newton per coulomb or Newton coulomb minus 1. It experiences a torque of 4 Newton into meter. The charge on the dipole, if we have to find out the charge on the dipole, if the dipole having the length is equal to 2 centimeters. So the quantity given in a data, that is electric field is equal to 2 into 10 raised to 5 Newton per coulomb, or it is in volt per meter also. Torque is given in 4 Newton into meter, and the theta is the angle between the dipole moment and electric field, that is 30 degree. So and the length between these two charge or dipole having the length is equal to 2 centimeter. Converting in meter, so 2 into 10 raised to minus 2 meter. So from the formula of torque, when the electric dipole is placed in a uniform electric field, it experiences a torque of Pe sin theta. Torque is equal to P cross E. So after simplify this, torque is equal to Pe sin theta, and theta is the angle between P and E, that is given 30 degree. So torque is equal to Pe sin 30. And what is the dipole moment? The dipole moment is nothing but Q into 2L. The magnitude of charge, one of the charge, and L is the distance between these two, that is given is 2 into 10 raised to minus 2 meter. So torque is equal to, in place of P, we write here Q into L, E sin 30. That theta is the angle between P and E, that is 30 degrees already given. So torque is given 4 Newton into meter. Q we have to find out. L is the length of dipole, that is in meter, 2 into 10 raised to minus 2. Electric field is given as 2 into 10 raised to plus 5, and sin 30 as a value is equal to 1 by 2. So after simplifying this, Q comes out to be 2 into 10 raised to minus 3 coulomb, so which is equal to Q equal to 2 millicoulomb. So the charge on a dipole is 2 millicoulomb, because dipole is consisting of minus Q plus Q. The charge on minus Q is minus 2 millicoulomb, and charge on plus Q, it is plus 2 millicoulomb. Question number 10. An electron falls raced through a vertical distance h in a uniform and vertically upward directed electric field. The direction of electric field is now reversed, keeping its magnitude same. A proton is allowed to fall from the rest in it through the same vertical distance h. The time of fall of electron in comparison to time of fall of proton is. That was asked in NEET 2018. That is the formula based question, that is Fe is equal to the electric force or electrostatic force. Fe is equal to QE. So in place of Q we take here electron, and the force is equal to Ma. So here in place of F we write here Me into A, where Me is the mass of electron, and A is the acceleration of electron. So subjecting A is equal to EE by M. This is formula of that was based on F is equal to QE. In place of F we write here Ma, that is force is equal to mass into acceleration, Q into E. So Q is equal to Ma by QE by that A is equal to QE by M. In place of Q we write here the charge electron. So the acceleration is equal to E small e, that is the charge on electron, and E is the electric field. Capital E is represent the electric field, and small me is nothing but the mass of electron. So the linear motion formula, that the h is equal to ut plus 1/2 at square. That h is nothing but a distance. The initial velocity of electron is 0. We consider as a 0. So h is equal to 0 plus 1/2 at square. In place of a we write here E by me. So in place of a put the value of a. In place of a we put here E by me. That small e is the charge on electron, and E is the electric field. Capital E is representing here electric field into T square. So h is equal to small e capital E T square by 2 me. So T square is equal to, subjecting the time, because we have to relate the time of falling of electron and time of falling of proton. So T square is equal to 2 meh by E. So T is equal to 1 square root of 2 meh by E into capital E. So T is proportional to, from this equation, that T is proportional to the mass of electron. Similarly, the T is proportional to mass of proton also. So as the time is proportional to mass, and the mass of electron, the electron is very light as compared to a proton, because proton is 837 times 18,837 times higher than that of mass of electron. That's why the proton is very heavy as compared to electron, mass of electron, and mass of electron is very light as compared to mass of proton. That's why the time taken for electron is less than always time of proton. So from this equation that mass of electron is less than mass of proton, the time taken by electron in falling as compared to the time of proton is very less. So smaller is the answer, that the time of fall of electron in comparison to time of fall of proton is very less or smaller. That option number B is correct.